Right, Chris, I suggest you make a start. Everyone on the meeting, if you don't mind muting your mics just in case of interruptions. And any questions, please post them in the chat and I'll interrupt Chris.
Brilliant. So right, well, thanks all for coming along. This is, as I've said at the start of all the sessions, new starter training, but everybody's welcome. And I particularly would value those who've been in the industry for a bit longer. If there's anything that comes to mind to you that, oh, we once talked about this, maybe something I've not touched on, just jump in the chat and let us know, and then we can always cover that. So that's all good. Duncan's recording it, as we have recorded the previous sessions, so that they can all be reviewed on the links that Duncan's going to put in the chat. And so without further ado, a quick overview. Last time we talked about design in a little bit of detail. It was the second session of design, and we got into some of the technical details around thermal response testing, pressure drop calcs, headers and connections, and various other bits and bobs. And then we also touched on the utilisation of the initial geology report, which I think is quite a useful thing that we do as part of the relationship. So today we are going to be doing session 4. I'm going to talk about the risks, and then we're going to do more of a question and answer. My feeling going into this was that the slides were going to take less time than in previous sessions, but actually having pulled the slide deck together this week, I think we're going to be probably 30 minutes or so on the presentation, depending on how much questions come out, but we'll still have a really good opportunity to do a Q&A at the end. And please use that opportunity in the Q&A if you've had a look at the previous sessions. If anything that's come into your mind from that, then just ask on anything really. So we're going to look at the types of risks that we can mitigate against, mainly around drilling, which obviously is a big part of what we do. And then I'm going to speak specifically about open loop. And if you're not familiar with open loop systems, session 1 we cover all of that, but open loop is where we take water from the ground, we water wells and put it back into the ground again. So as an alternative to closed loop. We're also going to plan in the next couple of weeks a review of a presentation that I did for Kenza's conference last year, which is on the utilisation of mines for these systems. I'm going to talk about mines today, but not from the point of view of using them as a source of water. So we're going to do a specific session on that in the next couple of weeks. So unless there's anything in the chat, comments or anything, Duncan, I'll crack
Nothing
on.
as yet, no.
Excellent. Okay, cool.
I'm sure actually, I've just noticed Stuart Gadsden has joined, so I'm sure he'll have some questions on the Oxford Artesian when we get to the Artesian section after this morning's conversation.
We love Oxford. So first of all, we're going to have a look at unexploded ordnance. I'm going to set this little video running at the side. So this is bombing activity during the Second World War, an animation going, so you can have a look at that as I'm talking. So Zetica UXO are a commercial organisation which has built up a really comprehensive database of unexploded ordnance risk. This is one of their animations. We use that service as part of our design reports, as part of our initial geologies, in fact, to recommend whether a more detailed survey is required. That more detailed survey could be on site, and actually as part of the requirements that drillers have to meet before they actually drill a hole in the ground, they do have to scan the site for services, and in many cases that would turn up something metal in the ground, like an unexploded bomb. In extreme cases, maybe in East End of London, for example, in sites that haven't been previously cleared, there might actually be need for a full on-site survey, and Zetica again do that service for you. So a great company to work with actually, and I've worked with them for many years, got a great reputation for their records and the quality of their service. So just that's unexploded ordnance. It's something we look at. It's something that can be a problem. What are we looking for with unexploded ordnance? I just thought we would show you. So here on the left-hand side is a fairly stereotypical Second World War bomb. That would be something like 1 metre long, or could be longer. But actually, we're also looking for smaller things. You can see on the left and the right-hand side, sorry, with a pen in there for scale, that these objects can actually be quite small. And even something that size, even if it is, 70 odd years old, is still a very, very dangerous piece of kit. So it is absolutely worth bearing in mind that these things can cause injury very, very easily, and can be in the site. So if you haven't seen the video of the unexploded bomb being detonated in Exeter, that's a link on the BBC website to see what can actually happen with these things. So another risk that we are concerned with is coal authority and other mines. So the mines that are looked after by the coal authority. So the coal authority has an obligation to look after these assets and make sure that the coal mines don't do anybody any damage, primarily. So in the areas you see on the map there shaded in black, they are the areas where permission to drill is required. And that permission is a legal requirement. It's a statutory obligation to get that permission. So if people are installing ground source in these areas and they're not getting permission, they're actually breaking the law. So it's very important to do that. So again, we check this as a matter of course, and we will recommend a course of action for you as part of our process. And then the process to get the permissions tends to take 2 to 4 weeks. Again, that's something that we tend to manage, and what the process is, it's quite technical. The cost in it is between £400 to over 2,000. It's on a case-by-case basis, and quite frankly, I can't work out how their pricing works. You just send your application in and they come back with a cost.
I can add to that, Chris. So at the moment, the Coal Authority is taking every bit of 4 weeks for applications. It's changed a little bit. The Coal Authority have 2 ways of pricing, either by land area for the permit boundary, or by the number of boreholes being drilled, and they will actually charge you whichever is the cheapest. So depending on regardless of what box is checked, on whether you want to be charged by area or charged by number of boreholes, they will actually switch to the cheaper option upon application. So they're very good like that.
Yeah, they are good people to work with. What I would say is they changed, as you said, alluded to a second ago, Duncan, they changed the process. It's a very detailed process. You do need to understand the geology you're dealing with to fill the form in. And they put in this clause now where you've got to get a sign off by the landowner, which is causing all sorts of problems. One of my roles, for those who don't know, is I look after the lobbying for the Ground Source Heat Pump Association, and we've written in very strong terms to the Coal Authority to object to that sign-off process. They haven't quite responded yet, but we keep chasing them on that. Occasionally, when you're along the borders of these shaded areas, you can actually negotiate out of permission. And so it's generally an email to them saying, look, we're right on the border here. Do you have a problem with this not getting permission? And they'll email us to say that that's okay or not, as the case may be. So that's the process of dealing with the Coal Authority. You'll notice that down in the southwest, down here, there is very little mining activity reported on the Coal Authority website. We know, of course, that Cornwall is very famous for mines. There are a lot of mines down there. And when we are in the vicinity of them, we've got other records that we have to access. They can actually be quite old records, and it can take quite a lot of detective work to find out what's in the ground. The good thing is about the Cornish mines is they tend to be very deep, so we tend to be below the level at which we are drilling. So most of the time it's not a problem for us. So I guess what is down there is an obvious question. So what risks and what mitigations are likely to be in place? So just let me talk you through. At the top here, we've got an older mine. These things can be stacked on top of each other. There can be many seams that have been worked over the years at various different depths at any given location. And an older mining technique would be to leave piers of coal in and dig around them to extract the minerals. And they would have dug all that out, abandoned the mine, and the voids would have collapsed. So to some extent or another, the ceilings of these things would have collapsed. And so what you've effectively got is a bunch of rubble at some depth mixed in with coal. And as I've shown there, this is, for those of you who are not familiar with chemistry, this is methane, methane gas. It's one of the most common pollutants, if you like, in coal mines. And it can be down there. The mines could also be full of water, and I'll cover it in the mine water extraction session next time. But that mine water can be quite dirty, full of particularly iron and manganese compounds. So you've got gases, you've got rubble, you've got unworked coal, you've got worked coal, and you've got water in there. So quite a difficult environment, although most of the time the drillers can't get through it. More modern mines would have been done with this hydraulic sealing support system. So this jack thing moves as this machine cuts the coal face out. And a lot of times these machines would have just been abandoned underground when the mine was abandoned. And I also illustrate there with my pretty poor drawing that these coal seams could actually be on fire. So that's another thing that needs to be considered when we are looking at engaging with coal mines. So that's the second thing we really need to consider is what's down there and what's the coal mines that we are likely to face. Cool. Any questions?
Chris, yeah, while we're on that, how do we drill through mines, and do they require casing?
They sometimes require casing. Many times, though, they can just go through them as if it's a void, any other void in the ground, and they just go out the other side. It can make completion of the borehole, so the grouting that we talked about in earlier sessions. So sealing that borehole up, it can make it a bit more challenging. And we sometimes have conversations with the drillers to say, you know, do we use gravel to fill that hole up rather than grout? And there are procedures around that. So it doesn't tend to cause too much of a problem for drilling, but it can cause a problem for completing that boreholes. And in very, very rare occasions, it can actually damage the pipes post installation. And on one project, we've lost 3 boreholes on that one project. But that's the only boreholes in my 20-year career in this that we've ever actually lost post installation. So any other questions?
How does the loop pass through the void?
It just goes through, it just hangs through the void. It can be a tricky process. It can mean that the loop gets stuck, but a lot of times because they put weights on the bottom of these things, they hang true and they'll just go down the bottom. If you're casing it, obviously, if you're putting a sleeve on the outside, then it just goes down the sleeve like any other installation. So the drillers are very skilled at this because obviously a lot of social housing, particularly, is in previously mined areas because of the social circumstances of the areas, and therefore, you know, the drillers have got very good at dealing with mines.
Yep,
Any of that?
That's the lot of your questions.
Oh, okay, cool. So the next thing we should talk about is groundwater. So groundwater can be a real challenge for drilling, and particularly if that groundwater is coming to surface on its own. So the term artesian is a bit of a misnomer amongst geologists, but what it means is groundwater coming to the surface on its own. Now this is ahead of a water well, so they've been looking for water here, and it's coming to the surface about 1 metre above the surface. So what we are interested in here is what flow rate is that going to have, and what pressure is it going to be under? So what height above the ground is that water spout going to come? Now you can imagine if you've got high pressure and lots of water coming out of the ground, that could not only be difficult to manage from a drilling and an installation point of view, but it could also be quite dangerous. As that water is coming up out of the ground, it can be washing out the sides of the borehole. So you could have, you know, subsidence problems in extreme circumstances. So all sorts of things it can cause problems with. Modest flows and pressures can be handled, and a very simple way of handling it is just like you see here with this water well. If you extend this casing up until it's above the pressure of the water, then the water's not going to come out of the hole. So very practical things like that. Other things that can be done is they can put air bags down the hole and then fill that bag up with air, which effectively seals off around, and that can be very effective at dealing with higher pressures if they are encountered. And just to make a note that there has been an installation in the UK where a water spout of 60 metres above the ground was found, and it was an actual ground source installation. So, you know, these things can be pretty violent. The other thing that's worth pointing out on this is that you might be a small installation company drilling one hole for Mr. and Mrs. Smith's bungalow, and you're just as likely to hit water with that one hole as you are on 300 holes for a hospital. So this applies to all scales of ground source. And it's something that particularly the Ground Source Heat Pump Association were very aware of and very concerned about, that people are going out without proper geological investigation, banging holes in the ground, and they may not be equipped to deal with it when it happens. So it's a great concern out there. Decent drillers, though, will go equipped, ready. They'll be warned by us and the geologists that they could have a problem, and they'll be able to handle it. So let me talk about what causes Artesian conditions, and so hopefully it'll give you a better understanding of what we're talking about here. So let's imagine we're going to be drilling a borehole here. This is maybe Sheffield or somewhere in amongst the hills, and we've got a river to the side there. So the first thing that you might think of is, well, am I going to have a problem with the river? So is there maybe a bed of gravel or something like that under the surface here? I'm going to be drilling through, that's going to be full of water. Is that going to be a source of potential Artesian conditions? Now, in actual fact, because the river level is going to be below the level of the ground, or else it would be a lake, then you don't have that head of pressure pushing the water out of the borehole. What you can have, however, is the drilling process itself forcing water out of the borehole. And that can be a problem. So if you've seen our reports, you'll sometimes see us in there saying, we believe the rest of water levels below ground level, but have mitigation for arisings. So what that means is the driller needs to go ready to deal with water coming to the surface, even if it isn't doing that on its own. So surface water, even in hydraulic contact with the surface of a borehole, tends not to be too much of a problem for us. However, much greater problem is if we have something like this. So, for example, up in the hills here, we've maybe got some porous rock, and that rock is going to get rained on, and that rain is going to filter over thousands of years down through the rock. And what can happen, the water level perhaps is up there, right up in the hills. And so when we hit that, water-bearing strata beneath, then what we're going to get is an equalization of pressure, which is going to force the water up out of the ground. And this is when you get these very big water spouts happening. So that's the general cause and the main concern for Artesian conditions. The other things that you need to have Artesian conditions is a confining ground condition above. So this needs to be, to an extent, impermeable, or else the pressure just wouldn't exist, and all of this would be a lake anyway. So there's lots of subtleties to it, but that's your general causes for Artesian conditions.
Yeah, we've got a question in, and I have a feeling you may have just answered the question with regards to your by using the slide.
Yeah.
Are areas in the south down more likely to have Artesian due to high water table in the chalk?
You tend not to have the problem. So in the Thames sequence, where the chalk tends to be, you might have a problem with arisings, but you generally don't have problems with Artesian conditions, no. So I'm going on to how we investigate it in a second, and maybe it's a bit relevant to one of my slides just in a minute. So I'll come back to that if that's okay, Duncan.
And also, is it possible to produce a map of the UK showing where Artesian conditions are likely to be found? I'm sure that already exists. There
are maps of the major aquifers, but I wouldn't like to. We have actually discussed with the British Geological Survey a hazard map where geology might be dangerous to drill in. So Artesian would be one of that. That doesn't exist today, but the BGS, British Geological Survey, have promised to look into that, so it doesn't exist. What we can say is that you tend to have problems in the coal measures in the middle of the country, either side of the Pennines. You tend to have problems in Lincolnshire with the limestones, and in Oxfordshire with the great oolite, which is beneath the Oxford clay. They are the main areas you have to concern yourself with. Certain parts of Wales also are a problem. So they're the main areas to be aware of. But no, a map, I wouldn't be confident in us producing it, but they are the areas that are to be concerned with. And if you're in doubt, just give us a call and ask us. You know, we don't necessarily even need to charge for a look to see if the geology is going to be a problem for you. So just utilise us to have a look for you. Any other questions, Duncan?
That's it for now.
Okay, cool. So what are we looking at? How do we assess the risk of Artesian conditions? Well, the first thing is we need to understand the geology in detail. There might be various different layers of ground conditions. They could be very different in their properties. And so we're looking at, do we have confining layers? Do we have notable aquifers? Do we have big elevation changes around? So that's the first thing we are looking at. Then we're doing some detective work. Maybe it's difficult to see, but that sign on there says spring close. Now, it might seem childish, but if you've got a road locally called Spring Close, there might be a reason for that, and it might be that historically there's been a spring there. Now, that spring could be, you know, just shallow water that isn't going to give us any problems at all, but it could be something a bit more sinister. So looking at it from that point of view is a good thing to do. Second thing, as I said earlier on, is we look at the relative heights and the hydraulics. So these things, just like the old roof tiler's trick of using a hose pipe with water in it to level up the tiles in a roof, the water's going to find that level. And do we have relative heights to then drive that hydraulic linkage? Our main weapon is accessing and understanding the available borehole records. Now, many of you may be familiar with these borehole records. They go back several hundred years. And this one's a bit of gold dust for us. So we've got water level at 337.5 feet. And that borehole record's there. We know that's a bit higher than our site. So we've got to take account of the hydraulic differences between the two that will let, the height difference between the two, and therefore the hydraulic gradient between the two, to see if that can identify the groundwater as below ground level or above. So if this difference here is less than 137 feet, we don't have a problem. If it's more than 137 feet, then we do have a problem. So it's understanding and accessing those records that really allows us to give some confidence. All of this is essential. So I mentioned, you know, Lincolnshire limestones, the Great Oolite, some of the coal measures around the Pennines. It's only through experience that you can really develop a spider sense, really, that rings when something like this could be a problem. And just finally to mention, it's the same with all the risk assessments we're talking about here. No assessment can ever be 100%. So that 60-metre spout that was encountered by one of the best hydrogeologists in the country, and the customer obviously got a bit nervous at that point, and they peer reviewed it, and the hydrogeologists who they got in all concluded that nobody knew it was there. So it was a completely undocumented aquifer under pressure, and so that can absolutely happen. So no risk assessment can ever be absolutely 100%. Any questions?
No.
Okay. So what other risks have we got? Services. Anytime you're digging a hole in the ground, services can be a problem. So gas, water, fibre, everything else that's buried in the ground. In London, there are something like 15 sets of permissions that are required to dig in a pit even, and so that's a key part of it. That's a scanner which actually scans to see if there's services in the ground. Tunnels, they can be a problem. Part of what we do in central London is we'll have a quick look to see if we're near tube lines. I've actually installed systems within 6 meters of tube lines, and that's perfectly acceptable to London Underground. There's no problems with that at all. But on the negative side, the HS1 line, fast high-speed rail link down to the Channel Tunnel, it was hit by a drilling contractor a few years ago. I hasten to say, not a ground source drilling contractor, but it was hit by a drilling contractor. So, you know, it could be very, very dangerous, something like that. Other things like plague pits, for example, lots of the cities around the UK have got plague pits where the bodies of victims of the Black Death back in the day were buried, and they can be a hazard to drill through. And then we've got other designations. So the Environment Agency has about half a dozen designations that might have an impact. So source protection zones, which is water protection zones for the ground. This is SSSI sites, so sites of special scientific interest in England, Wales and Scotland. So they can have a bearing on what we can do, the methods which we can use to do it, and whether we need permissions or not. This is an unusual one, but it does exist in a few parts of the country, under South East London and under Bath, notably. There are quarries, underground quarries. So Bath stone is famous for being used. A lot of the city of Westminster was built with Bath stone, for example. And these things now, these abandoned mines, are often now used as tourist attractions. The one in southeast London, at Cobham, I think it is actually a party venue, apart from anything else. So there are things in the ground that we've got to be aware of. Use local knowledge is very helpful. And the list goes on.
I think a lot of Westminster was built using beer stone down in the West Country here.
That's right. Yeah, exactly. So that's a high-level summary of the other risks that are there. Again, you can't eliminate them all, but they are all to be considered and mitigated against. Any questions?
No.
Okay,
just me interrupting you.
Okay, no bother. Right, so second part of what we're going to talk about is open loop risks. This is slightly different. This is not what can go wrong while you're drilling. It's more when we're going into a project using water wells, what have we got to be aware of? And one of the first things we need to be aware of is the nature of the aquifer that we are involved in. So the first one is intergranular flow. So water flows through the rock itself. So imagine a pumice stone, dip it in a sink of water, lift it out, the water will pour out of that pumice stone. So that's exactly what happens. And the grain size varies, but that's what's going on. This is an outcrop of the Sherwood sandstone, which is one of the major aquifers in the UK. It's a largely sandstone aquifer, and water actually flows through the rock itself. So when we're drilling for water in the Sherwood sandstone or other intergranular flow aquifers, we're not relying on anything other than hitting the rock to hit the water. So it's actually a relatively low risk opportunity is to drill for water in these sandstones and limestones, particularly in the north of England, the Midlands north, basically. There is another type of aquifer, however, which is a fissure flow aquifer. So that's where water flows through cracks in the rock. And the best example in the UK, this is Beachy Head, and that's the same chalk that extends underneath London, and that's the major aquifer that sits underneath London. It's a fissure flow aquifer, so if you don't hit the cracks, you're not going to get the water. So a lot of the drilling in London is about have I hit the cracks. If you get an absolutely dry borehole in the chalk in London, there's actually very little you can do about it. If you get a little bit of water, then you can put acid down that borehole, hydrochloric acid, which reacts with the chalk, neutralizes itself, but opens up the cracks and fissures. So you can therefore improve the yield. But if you get nothing, there is very little you can do. And I had one project back in the day at contracting where we had to convert from open loop to closed loop late in the day because we just got nothing out of that first water well. So again, geological investigation can look at these types of things and assess what our risk is likely to be. So it requires a detailed desktop assessment. We've got Environment Agency risks. So the process of dealing with the Environment Agency, which again is a statutory process when you're putting water wells in above 20 metres cubed a day in terms of the extraction rate. You've got to get permission to do the drilling in the first place and then a license to operate that well long term. And there are risks associated with that process. What I mean by that, if you apply, they may not give you permission to drill at all. That's happened to one project that we were looking at down near Duncan in Devon, where the aquifer is so under threat that it just refused permission to do anything at all. Unusual, in fairness, with ground source, because all the water we're taking from the ground goes back in, so we're not depleting the aquifer, and I deal with that in an earlier session, but that can happen. Once you get your permission to drill, it's very unlikely, provided something really unusual comes up, that you're not going to get them permission to operate that system. It could happen, but it's very unlikely because they've given you permission to drill in the first place. Other risks associated, though, with the Environment Agency is they may request additional modelling to be done of the hydrogeology and the effect of moving that water to and from two boreholes is going to be. They may ask you to do some thermal modelling to look at any heat plumes, for example, that might be dissipating away from systems, particularly when you've got lots of systems in a small area, like you have in central London, for example. Manchester's another city which is going to be heavily exploited with open loop projects over the next few years. So there are risks associated with the Environment Agency. I'm not going to talk today in any great detail about the risks associated with taking water to and from coal mines or mines in general, but I'll deal with that in the other session that we're promising for the future. Well construction is very important, so it's important to construct the well in such a way that you minimise risk of problems during installation or problems post-installation with maintenance requirements. So that's important, is to get that well construction right. And then with open loop, you're always going to have ongoing maintenance requirements. Because we are dealing with untreated water, you're going to be taking that water has variable content in terms of minerals, in terms of particles and so on. So it will always have an effect on the equipment that's used to pump it, move it around, exchange heat with it, and so on. So there are always going to be ongoing maintenance requirements with open loop systems.
I've got a question, Chris.
Go on.
When you're obviously taking the risk to do an open loop project and you're needing to hit water, can you test for water with a test bore that is just 150 millimeters, or do you need to go to the expense of drilling and constructing an open loop water well?
Unfortunately, the information you can glean from doing a narrow diameter borehole is limited to really understanding what the water level, the rest water level as we call it, so what the water is sitting at in the ground. You can generally tell what that is, but in terms of what flows you're going to get out of it, it is of very limited use indeed. So unfortunately with open loop, you've kind of got to commit to that first borehole before you can really de-risk it. And so that's why we spend so much time doing desktop analysis of it, to really try and characterise what that risk is in advance of committing somewhere between 12 and 120,000 on a borehole. Any other questions come in?
No questions in the chat, no.
Well, should we just throw it open to a discussion?
Yeah, if anyone has a question, please unmute yourself.